On question number 5, we are given a curve and a straight line and asked to find the region bounded by the curve and the straight line, so the shaded region R. Now, there's two different ways we could do this. One option would be to just integrate the curve from 0 to whatever this x coordinate is. So if you integrate the curve, we would get all of that area there. And then we could work out the area of this trapezium, right? And then subtract the trapezium, and that would give us the shaded region. But I'm going to do this slightly differently. And a good way to do this, if you have two curves, or a curve and a straight line, like in this case, and you're trying to find the shaded region between the two curves, a simpler way to do this, so let's say, for example, I have the equation of the curve on top is y1, the curve on the bottom is y2. Rather than integrating them first and finding the difference, you can find the difference first, simplify that, and then integrate that between the limits. And this often is easier than having to find two different area and subtracting them. So, and if you're doing this, you always need the curve that's on top minus the curve on the bottom. And this is especially useful if you have, let's say, some part of the curve that's below the x-axis and some part of the curve above the x-axis. You can just do this and it will just give you that area. So what we'll do here, so first of all, we do need to know this coordinate. So regardless of which method we use, our integral is going to be from 0 to that coordinate. So to find that point, all we have to do is just make these two equal to each other and solve that quadratic equation. So I'm going to have 9 plus 2x minus x squared is equal to x plus 3. Let's move everything to one side. So I'll take all the terms to the right hand side. So I have x squared minus 2x, so that will give me minus x. Then subtract 9, that gives me minus 6 equal to 0. At this point, you can just put this into a calculator and write down the two x coordinates. Here it's easy enough to factorize this, so I'll say x minus 3, x minus 2. Sorry, x minus 3, x plus 2. So this means either x is equal to plus 3 or x is equal to minus 2. Now we'd want to ignore the x equals minus 2, so I'll just cross out the x equals minus 2 because that would be the coordinate for A. Right? So clearly from the graph here, we want the positive x value, so we know it crosses the x-axis at plus 2. So this tells us we need to integrate from 0 to 3. Now, so the method that we just discussed, so I want to take the curve that's on top, which is 9 plus 2x minus x squared. So this is where I'm going to work out y1 minus y2. So 9 plus 2x minus x squared. And from this, I want to subtract the other equation. So the equation that's on the bottom is x plus 3. So if we simplify this, this would give us, so 9 take away 3. So imagine if you expand these brackets, that's minus x minus 3. So 9 take away 3 gives us 6. 2x take away x gives us plus x, and then minus x squared. So to find the shaded region, all we need to do now, so we don't really need to worry about a trapezium. We've already subtracted the two equations. We can just integrate this equation. We could integrate 6 plus x minus x squared in between x is equal to 0 and 3. So doing the integration, this would just give us 6x plus x squared over 2 minus x cubed over 3. And the limits for this one would be from 0 to 3. So we then just need to substitute these numbers in. So in the exam, you could just substitute this in your calculator and you could write it down. So this is going to be 6 times 3 plus 3 squared over 2 minus 3 cubed over 3. Although having just said you could just substitute in the calculator, given that the answer is already given, we really should show that this is what it would simplify to. So subtracting 0, everything will be 0. So this gives us 18 plus 3 squared is 9. So plus 9 over 2 minus 3 cubed is 27. 27 over 3 is equal to 9. So on the calculator, if you were to do 18 take away 9 is 9 plus 4.5, that does give us 13.5. So the shaded region is equal to 13.5.